today's lesson. Today we're going to talk about prime factors. Now, if you didn't do yesterday's lesson, at the end of it I explained how to find all the prime numbers up to 100. So if you haven't done that, you can go back and have a look so that you understand what the prime numbers are. It's really important that you have a reference so you know what the prime numbers are. Now, all whole numbers that are not prime numbers, we call them composite numbers. Composite meaning made up. They're composite numbers because they are made up of prime numbers. They are made up of prime numbers by multiplying them. Let me demonstrate. So if we take the number 4, to find 4 we can multiply 2 times 2. And yesterday in the lesson I demonstrated that 2 was the first prime number. If we take the number 6, I can demonstrate that by saying it's made up by multiplying 2 times 3. 2 is a prime number and 3 is a prime number. If I was to take the number 8, can I use prime numbers to multiply to make the number 8? Oh yes, I can, because if I multiply 2 times 2, I get the answer 4, and then if I multiply 4 times 2, I get the answer 8. So I have used 3 numbers, multiplied 3 numbers in order to create the answer, and that's what means that these are composite. If you were to try and do that with a prime number like 7, the only answers you can get are 7 and 1, which is a prime number. So these composite numbers you can make up using prime numbers. Let me demonstrate maybe a slightly longer one, something like 16 for example. You could do 2 times 2, which is 4, times 2, 8, times 2, 16. Or let's do one like 15. Again, 15 is not a prime number, it's a composite number because it can be made up of the third prime number, 3, and 5. 3 times 5. So these numbers, prime numbers, can be multiplied to create composite numbers. And today what you're going to do in your maths lesson is to create factor trees using prime factorization. So a factor tree would give you a number, say for example 12, and you've got to think, okay, which 2 numbers do I multiply together to make 12? So you could say 12, okay, 3 times 4 is 12. Now, because it's prime factorization, you always want to end up with prime numbers at the end. So 4 is not a prime number because it can be multiplied by 2 as well as by 1 and 4, 1 and itself. Which is why, if you have that grid of reference, I just show you what we did yesterday. If you have this handy, you can see that 4 is not a prime number. So we need to keep going. 3 is a prime number, so we can leave 3. We need to then factorise 4 into 2 times 2. Now, the method that we use is that we bring that down, and then we say to ourselves, okay, I have factorised 12, I took 12 and I factorised it. 3 times 2 is 6, times 2 is 12. So I have ended up with all the numbers which multiply together that are prime numbers, which give you the answer 12. Let me demonstrate with another one. Oh, we could try 12 again, where we take 12 and we say 6 times 2. Now, 2 is a prime number, so that's fine, but 6 we need to factorise. We could make 6 3 times 2. Is 3 a prime number? Let's just double check. Let's go back here. Yes, it is. Is 2 a prime number? Yes, it is. So I'm going to bring this one down, and that gives me my prime factorisation. 3 times 2 is 6, times 2 is 12. So it shows you that whichever route you take, you always end up with the same answer. It doesn't matter what you multiply by, doesn't matter which choice you make, as long as you keep going until what you are left with is prime numbers, you have created a factor tree, and this is what we call prime factorization, where you keep going until you've got numbers which when multiplied together give you your original number. And when you're working in your book, we would like you to set your work out like this with a factor tree. So remember, if you end up with a prime number but you're still factorising, we bring this number down so that in the end you've got the numbers which multiply together to create the original number. So you're going to do some lovely work on prime factorisation today, where you create these factor trees and you end up with prime numbers. There's a lovely factorising mastery challenge which I had to go through myself to find the answers, and I really enjoyed it. So I would recommend that when you're finished, whichever level you do, you have a look at the mastery challenge today, because it was good fun and it really makes you think a lot about prime numbers and prime factorisation. So enjoy today's lesson, and we'll see you tomorrow.